All right, so we're going to talk about finding the distance of 2 points. So the way we're going to do that is we're going to use Pythagorean theorem. And to do that, it is a squared plus b squared equals c squared. Okay, so first I got to make myself a right triangle. That's the only way you can do this. Okay, so I'm going to do a's as up and down. So I'm going to count 1, 2, 3, 4, 5, 6. So that means that a is 6. My b's I make my base, so that'd be 1, 2, 3. And we're asked to find c. All right, so 6 squared gives me 36. 3 squared is 9. Okay, we're going to add them together. That gives me 45. And when you get to this point, okay, you got to take the square root of both sides. And to get that, when you take the square root of 45, you get 6.7. So that means that that distance of that line is 6.7 units long. Okay, let's do another one. Okay, sometimes they don't give you grids, so sometimes you're gonna have to graph it yourself. Okay, so they give me A as negative 4, 1. There's A. B is at 3, negative 1. There's B. Okay, so we'll make our right triangle. So again, it's A squared plus B squared equals C squared. Okay, A is always up and down, so that would be a distance of 2. B is always side to side. Okay, so we know 2 squared is 4. 7 squared is 49. Add them together, you get 53. And then when you get to this point, you always got to take the square root. And you get 7.3 is the distance of that line. Okay. Last one, same idea. Okay, plot your points. So it's negative 7 is right here. Negative 7, negative 2. There's my E. F is at 11, 3, which is over here. Okay, so we'll make a right triangle. Okay, so if we're doing A squared plus B squared equals C squared. Okay, again, A goes up and down, so 1, 2, 3, 4, 5. It'll be 5 squared plus my B squared is all the way all this across. 1, 2, 3, 4, 5. And when you add them all together, or to count them all, you get 18. So 5 squared is 25. 18 squared is 324. When you add them together, you get 349. So last but not least, take the square root of both sides. You get 18.7 is that distance of that line.